example 8.4. There is a sphere of mass m. See, there is a sphere of 4 in a radius r. Can what center to center distance. This is 6 r. Now to be done, a projectile of mass m project from where
Surface of the sphere of mass m.
Okay, so let's call this C1. C2 sphere 1, sphere 2 may nothing. So m is here, it is to be projected, small m.
Directed towards the
center. They are from surface of this in this direction. Understand? Right? This is to be thrown from here in that direction. Okay? So this is current. Obtain the formula for minimum speed.
so that it reaches
the surface of second. Okay. And it should reach up there. Right? So you can imagine that this equation is as follows. Similar. A pen, हमारे pen moon पर पहुंचाने हैं. Okay, pen moon पर. Okay, नहीं जाए. क्या नहीं? Speed is not enough. I'll throw it. It will go high. But then what will attract it? Earth, and it will bring it back. Clear? So you have to throw it fast enough so it can reach the moon. You have to throw it from here. It should be fast enough so that it can reach the other one. Right? Okay. But you see, you don't need to send it all the way. There is one little thing here. Suppose you consider that there is one point here. Let's call it P. And if at that point the force on the mass m due to sphere 1 and the force on the mass m due to sphere 2, if these two forces are equal to each other, then you only need to send it to P. Yes, because beyond P, the mass 4m will attract it and it will bring it to the surface. Concept clear? Our aim should only be to send it to P, because once it reaches P, okay, with a negligible speed, okay, not exactly 0, but very small also is enough. So if it will reach here with a negligible speed, so it will go a little bit forward. So the moment it goes a little bit forward, this point, this mass will attract it more than this one, and it will bring it towards the surface. Do you remember that question where we found equilibrium point between two spheres? I think the last question in exercise. Okay, so if it goes slightly right side, it will get attracted towards that. Understood? Or not clear? So we don't need to send it all the way to this point B. Suppose we need to send it only from A to P, but we don't know where is P. But yes, we know that P is that point. P is that point where the total force acting on the mass m shall become 0. That's it. You send it little bit forward, little bit negligible, small distance ahead, and then done. Then 4m will attract it and bring it to the surface. Clear? So at P, Fm is 0. So can we find how much is this distance? Okay, so let's say this is x. So we try to find out this distance. So at this point, Fm vector is 0. So what can you say about these two? The forces are equal in magnitude, correct? So we will have Fm1 equal to Fm2. Again, this is at which point we are doing all this calculation for point P. Okay, do it. Come on. Fm1. What will be Fm1? Force between this mass m and here. So the G capital M small m divided by x. Okay. If the distance on this side is x, what's this remaining distance? What's the remaining distance? 6r minus x. Alright? X. 6r minus x. Equal to. Right side
4G
4G capital M M divided by 6R minus X whole square. This time because mass is 4M and the distance is 6R minus. Solve it. When you take square root, you get plus minus, but one answer will be nonsense. Let's take square root. It's easier.
one by
X equal to
2.
or we can use the shortcut. This is 4. X square root. So 2. And then 2 plus 1, 3. We have to divide 6R in 3 parts. So one part is X and 2 parts is this. So X will be equal to 1 part out of 3 parts of 6R. Okay? So that is 2R. Right? Or you can solve this equation. Ultimately, we get X equal to 2R when you take square root. So we get X is 2R. Now, if X is 2R, we know where this point is. So now our aim is to only send it from A to P. And that's it. So even if it reaches P with a negligible velocity, it will overshoot. Overshoot means it will go slightly ahead. And that's enough. If it goes slightly ahead, then 4x is ahead. So let's write it. Okay. For sending the particle from surface of sphere 1 to sphere 2, we only need to send it from point A to P. Okay, we only need to send it from point A to P, right? Okay, so you can write that we want P, 4M will attract it, that is sphere 2, because the sphere 2 will attract it and it will reach the surface. It will reach the of sphere 2. Right? Now let's find out how much is the speed with which we need to send it. So let's say we need to send it with the speed v. So initial speed we know, and we just need it to reach it here with negligible speed. Just like SK, if you remember. Okay, at infinity, if you want to find minimum speed here, then here the speed should become 0, just like it used to be 0 at infinity. Right? So, for minimum speed at A, Vp should be equal to 0. That is negligible actually. Okay, so 0 exactly won't do, but 0.000001 would do. Or even smaller than that would do. So actually it's a limit tending to 0. Right? Anyway, so for A to B. So now our aim is only to send it from A to B. So K1 plus U1 equal to K2 plus U2 because we know about velocities. Right? We know this velocity is 0 and we want to find this velocity and the distance, we know that. So K1 half mv square. Potential energy. Now, here in this whole thing, in this whole system, how many objects are there? 3. Isn't it? Small m, capital M, 4 capital. 3. So, when we write potential energy of the whole system, we'll have 3 terms: U12, U13, and U2. Okay, but there is one thing about potential energy. Potential energy change is important. The value is not important. So if you think about it that way, there is one potential energy, one term out of those three which will never change. These two are fixed. So do you realize that their mutual potential energy, that is potential energy of M with 4M, that will never change. Clear or not clear? Only the mass small m will move. That means potential energy of small m with these two will change, but potential energy of mass capital M with 4 capital M will not change. So you can ignore that one because only the change is important. You don't need to worry about it. Suppose you don't ignore, no problem then. Write all the things, that term will always get cancelled. So potential energy. So first of all, small m with capital M. So minus G capital M small m divided by. That's the point mass outside the sphere. So we have to take the distance from center, that is R. Initially A per. Okay, this is for A. Now M with 4 capital M. Small m with 4 capital M. What should I say? Minus G 4m small m divided by 5. Clear or not clear? R from left side. So 5 are from right. Total is 6 R. Okay, third term which is fixed term. Which one between these? What do we get? Minus G 4m M upon 6 R. Okay. Now right side you are going to have to tell me the potential energy. K2 is 0 at the point P. So now what this means is now this particle has reached P. If you want, I draw a new diagram, otherwise it's okay. We just need to be clear what we are doing. Now we are talking about this over here. Mass M over here, not over here. Okay. K is 0. Potential energy minus, first of all, this with that capital M. Minus G capital M small m divided by 2R, because now we know that X is 2. Right? Now small m with 4 capital minus 4GMM by 4 because 2 are on the left side, so 4 are on right side. And last one, between capital M and 4 capital M, that potential energy is minus G into 4M into M divided by S. I was telling you. This term is constant. So even if you don't write it, it's fine. Because it will always get cancelled whenever you use it. Cancel. Now we have to find out what is V. The easiest way to do it is cancel small m and then take 4m, G, M and R common. Do it fast. So we are getting V squared by 2 equals, on the right side, Gm by capital R is common. First term 1, second one plus 4 by 5, third one minus 1 by 2, and last one, this one 1, because 4 by 4 is 1, and this term. Okay, so this is 8 minus 5, 3 Gm by 10R, and this is V square by 2, so we get a week or 203 them by 5. Okay? So that's it. So key thing to understand is that you don't need to send it to P. You only need to send it to P. Right? That will do. Okay. Now next example. 8.5. The planet Mars has two moons, Phobos and Deimos. Phobos, so first question, Phobos has a period of 7 hours 30 minutes. So time period of Phobos is given. First part. Okay, question 1. Time period is given 7 hours 39 minutes. 7 hours 39 minutes. And orbital speed, that is, orbital radius. Orbital radius of 9.4 into 10 raised to 3 kilometers. So T is given and R is given. Calculate mass of Mars. Calculate mass of Mars. Phobos is revolving around Mars. So use that time period of revolution formula. T square equal to 4 pi square. R cube divided by G M. Instead of mass of Earth, we will have to write mass of Mars because Phobos is revolving around Mars. Okay? Just put values and get the answer. Right? Do it later. Okay, second. Assume that Earth and Mars move in circular orbits around the Sun. Okay, second part. Okay, we have to assume that there are two planets, Earth and Mars, both are moving in circle around the Sun. Okay. With the Martian orbit being 1.52 times the orbital radius of Earth. So, what's given in the second question is that radius of orbit of Mars is 1.52 times.
Radius of Earth.
Example 8.5, question 2. Radius of orbit of Mars is 1.52 times radius of orbit of Earth. So if we draw diagram, here is Sun, this is Earth moving in circle, and this is Mars moving in another circle. Right? So what do we have to find? What do we have to
The length of Martian year.
What is the length of Martian year in days? That is, Martian year means one thing of 1 year, the time in which the planet goes around and comes back. Okay, 1 year. Okay, so we have to find time period of revolution of Mars. Understood? We have to find time period of revolution of Mars. In what unit? In unit days. In unit of days. So both are revolving around Sun. So we can directly use the idea that T square is proportional to R cube because both are revolving around the same orbit. Clear or not clear? Sure. So from this we can write Pm square upon 365.25 square. Tm upon Te. Time period for Earth's revolution is 365.25 or something is given, you can use that. Equal to, what should I write now? Rm upon Re, and then you can propose. Is Rm given? Yes, Rm equal to 1.52 Re. Put it, calculate, get the answer. So you can also take experiment first. It's easy then. 365.25 multiplied by Rm upon Re, that is 1.52, the whole raised to 3. Okay. Now example 8.6. 684 days is the answer. Yeah, no. Huh? 468. 684. What so this TF is equal to 365.25 multiplied by 1.52. It's square root and then cube. So 1.52 square root and then into equal to like that. Okay, cube or cube first and then x first. It's fine. 1.52 into 1.52 into 1.52 and then square root. So what do you get here? 1 point 2.5 1.23. Are you sure? Calculator use करो क्या मालूम करो 1.52 square is 2.3 into 1.52 3.5188 divide 80 square root 1.873. So mistake करी थी ना 1.87. So multiply that, right? Okay. Now, 365.25 के मैंने cover पड़ी ना? Day माटे. Okay. Year लखवानो है तो 1 જ લખે. That would be easiest. Okay. Weighing the earth. Example 8.6. Example 8.6. You are given following data. Okay. So we are given some data here. Based on that, we have to find mass of Earth. Weighing the Earth means finding the mass of Earth. Example 8.6. In fact, we talked about it yesterday. So it says G is 9.81 meter per second square. 1 meter per second square. RE, that is the radius of Earth, is 6.37 into 10 raised to 6 meter. Distance of Moon from Earth is given to be 3.84 into 10 raised to 8 meter. Okay, distance of Moon from Earth. So that is written as R in this question. And time period of revolution of Moon is 27.3 days. Obtain the mass of Earth in two different ways. Okay, you have to find the mass of Earth in two different ways using all these numbers. Right? So basically we just have to establish a relation. We know G's value on Earth's surface is GE. From GE we can easily find the mass of Earth. What's the formula of GE? GE equal to GME by RE square. So this is one way to find mass of Earth, isn't it? M equal to RE square, okay, into GE upon capital G. Clear? Put all values and get there. The second way. The question says obtain mass of Earth in two ways using all these numbers. Right? So the other way is that if you are going to use the time period of Moon's revolution, then by using a similar formula, which is d square equal to 4 pi square by GME, because the Moon revolves around Earth, R cube. Okay, and what is R here? Small r is going to be capital R, because the radius of that orbit is capital R. Okay. So just put the values and get done. Okay, done. Right. Example 8.7. Express the constant k of equation 8.38. Alright, 8.38. So first of all, let's write the equation 8.38 in this example 8.7. Okay, these are all fairly stupid questions. Equation 8.3. Right? So what's that equation 8.38? Where you get it?
P square
P square equal to k times
R plus H whole cube.
R plus H whole cube. You can also write it like this. Okay, R plus H above the surface of Earth. I think there are some satellite here, so you can always write small r equal to R plus H. Okay, now what's to be found? Obtain, express the constant k in days and kilometers. And given that what k's value is, k equal to 10 raised to 10 raised to minus 13 second square meter raised to minus 3. Okay, s square m raised to minus 3. तो देखा है t square s square upon meter cube. We just have to convert to which unit? Days and kilometers. How does it convert करता? 1 day is how many seconds? 86400. Okay. So from that you can easily convert, isn't it? How does it? So let's use that 1 day 86400 seconds. So 1 second will be 1 by 86400 day. But just use that over there. Okay, on a meter cube. So 1 meter cube is 10 raised to 9 kilometer cube. Isn't it? Because 1 kilometer is 1000 meters, so 10 raised to minus 9. Therefore, k equal to 10 raised to minus 13 into s square. Instead of s, we are going to write this. So 86400 square. Clear? Unit conversion समझाए थे कि ना समझा दो? ये जवाब को भी पढ़िए. Upon meter cube. This is upon meter cube. So 1 meter cube is this. So upon 10 raised to minus 9. And now the unit is day square kilometer raised to minus. So
10 raised to minus 13.
2 minus 13. Sorry, minus 3. Okay, so that is it. 10 raised to minus 13 from the value. 10 raised to minus 9 is conversion, and 1 by 8 equal to 0. I don't know whether we can say that this is a 11th standard question. Okay. The moon is at a distance this from Earth. So once you find this, okay, so take this value, and then put this value as t square equal to kr cube. So after you do that, you can put time period of revolution. How much is given? Of moon. Okay, you find time period and distance of moon from the earth is given. How much?
3.84 into 10 raised to 5 kilometers.
3.84 into 10 raised to 5 kilometers.
Surface is the center.
It wouldn't matter because compared to this, it's very okay. So it doesn't matter. So if you put all these values here in this, you will be able to find time period. Okay, I'm leaving it for you. I think it's fair enough. You just have to put R value. Now you can use these units, mind you. The whole exercise is about allowing us to use kilometer and day. Right? Okay. Now example 8.8. આ બધામાં કઈ કન્ફ્યુઝ નહીં થઈ જાવ ને તમે લોકો ડરી નહીં જતા કઈ નથી હોતું આ બધામાં કેલ્ક્યુલેટર લઈને મંડી પડવાનું right convert units this to that એવું છે use proper units and you will get the right answer by putting it in formula okay example 8.8 this is worth doing unlike the last 2 or 3 so what does it say a 400 kg satellite is in a circular orbit of radius 2 RE about or around the Earth. Draw the diagram. So, satellite has mass 400 kg and it is revolving in a circular orbit around the center of Earth. Okay, radius to the orbit to 2 RE. Okay. Then how much energy is required to transfer it to a circular orbit of radius 4 RE? So from this orbit, you have to move it to another orbit. Okay, a larger orbit. So this is Earth, and let's say here is the initial orbit of that satellite. Okay, what's the radius? 2 RE. Now from there we have to move it out and send it to a bigger orbit of a radius 4. Okay? Right? So how much energy is required? See, it's fairly simple. Yeah, let's take an analogy. Suppose you have 10 rupees. Okay, and you want to buy something that's worth 30 rupees. How much energy is required? Understood? So basically, when we do external work on this system, which system called satellite, its total mechanical energy will increase. Clear or not? Pela 10 હતી સમજો. હવે 30 કરવાની છે. So how much is required to be given from outside? 20. How 20? Final minus initial. Got it? I don't know W external. That energy has to come from outside, from something else, not Earth, not satellite. So W external equal to delta E. So E2 minus E1. Okay, what is E2 in the second orbit and first orbit? What's the formula of mechanical energy of satellite revolving around the Earth? Minus G MEM by 2 small. Isn't it? Yes or no? Sure. યાદ આવ્યું ને જોઈ લો નો યાદ હોય K U અને E ત્રણે જોઈ લો એકવાર મને તો યાદ છે તમને યાદ હોવું જોઈએ બરાબર minus GMEM by 2 smaller. What is the smaller in case of second order? 4 very good. So પછી minus plus GMEM by 2 into 2 okay, take it common. So GMEM by 2 RE common. Okay, then what's left behind? 1 by 2 minus 1 by 4. Okay, GMEM by 1 by 4 minus 1 by 2 is 1 by what? Hello? 1 by 4. बराबर ने यहाँ जैसे 8. Okay. Sure you got that? चलो आ जाएगी एनर्जी लेट्स पुट वैल्यू मान लो ये बोल रहा है ने बट you see we can play one trick here instead of putting G M E and R and all that let's divide and multiply by R okay it will be easier than that after that you G M E by R square is G that is 9.81 divided by 8 into radius over 6.4 into 10 raised to radius of Earth 6 बराबर है भूल गया 6400 किलोमीटर ये 6.1 to 10 raised to 6 with mass m कौन mass satellite what the satellite 400 answer will be in joule work or external work energy required you can write energy required or external work required is this. What is? Are you sure? બે વાર કરી દે. હા એટલે પર એક્ઝામ માં 3 વાર કરવાનું. It can be very dangerous. Calculator બહુ ખતરનાક વસ્તુ છે. મિસ્ટેક છે તમને ખબર ન પડે. કારણ કે સ્ટેપ્સ તો દેખાય નહીં. શું આવ્યું આન્સર? 3.12 into 10 raised to 9. चेक करो 2.7 के बेबी છે. ઓકે થઈ જાય છે કે આગળ પાછળ આવે જરા 3.13 આવે ને 14 આને તો 4 આવે 3.14 3.139 એટલે 3.14 તો થાય પછી અને that's it તે કેમ 3.12 કીધું તે કીધું તો જોરથી બોલ ને ચલો થઈ ગયો ને સેટેલાઇટ એનિમેશન ની એક્સરસાઇઝ ઠીક છે બેલ પડી ગયું 19 is homework. Expanded means given. Expanded means given. And a given question there. There the satellite is revolving. The satellite is revolving, and we have to give it energy so that it escape. Something else, so that it should escape. Clear? So basically, if you want it to escape, its final energy should be 0 or more. Escape becomes free. That's a bound. If the system is bound, its energy will be negative. 0 or greater means free. Negative ma bound. 0 or greater means free. So in જે પણ E હોય એમાંથી finally E ની value શું થઈ જવી જોઈએ? 0. Clear? It will be negative, means it is bound by Earth. If you make it 0, then the satellite becomes free. This is the easiest way. બીજી બધી મેથડ છે એમાં વેલોસિટી ફાઇન્ડ કરીને પછી એસ્કેપ વેલોસિટી કરો ને એવું બધું. એસ્કેપ વેલોસિટી આપો તો એ ફ્રી થઈ જાય. બટ ધીસ ઇઝ ઇઝી. આ એક લાઈનમાં આટલું બોલ્યો ને એનાથી જલ્દી તો તમે લખી લો. બરાબર? If you pick the right. Okay? Energy is equal to, right?